This session is a continuation of the Chapter 5 review with Problem 8. In these two problems, 8 and 9, decide whether enough information is given to prove that triangle WXZ is congruent to triangle YZX using the side-angle-side congruence theorem. If so, prove. Write a proof. If not, explain why not. Well, in Problem 8, what we have is we know that this side is congruent to this side, this angle is congruent to this, as evidenced by these little marks, and also we know that side XZ is congruent to itself by the reflexive property of segment congruence. But this only gives us a side, and an angle. And as we learned in the chapter, that is not a theorem of congruence, and it is especially not the side-angle-side theorem. So our answer to number 8 is that no, there is not enough information to show that triangle WXZ is congruent to triangle YZX by the side-angle-side theorem. So stated formally, no, there is insufficient information to prove the triangles are congruent with side-angle-side, since we only know two adjacent sides and a non-included angle are congruent. And now on to problem 9. In problem 9, we're given that WZ is parallel to XY based on these two parallelism symbols. We also know that ZY is congruent to WX. And so now we need to determine, do we have any angles and any sides? And in fact, because of these two parallel lines, we do have some congruent angles and another congruent side. We have this angle and this angle are congruent. So let's go ahead and put in some marks here. Because these two sides are parallel, this is a transversal. If two parallel sides are cut by a transversal, then the alternate interior angles are congruent. So here we have an angle. We know that this side, XZ, is congruent to itself by the reflexive property, and we're already given this side is congruent to this side. But unfortunately, even with all this information, we're still at the point where we have side, angle, side, angle. And of course, that's not a theorem. Now, it's my unfortunate duty to point out that the author erred in stating that this angle is congruent to this angle by the alternate interior angles theorem. And in fact, these lines are not parallel, or they're not shown to be parallel. We can prove that, but not directly. And so we can't state at this moment that this angle is congruent to this angle. So as this picture is drawn with this side parallel to this side, there is not sufficient information regardless of what the author's answer is. If they had said that this side was parallel to this side, then we would have had that. We would have had that condition where these two angles would have been alternate interior and they would have been congruent. But we don't have that, so we can't show that these are congruent triangles by the side-angle-side theorem. So again, we must report, no, there is insufficient information to prove the triangles are congruent with side-angle-side, since we only know two adjacent sides and a non-included angle are congruent. Now on to problem 10. In problem 10 through 13, we're using this picture to show these statements. So it says, copy and complete the statement. If segment QP is congruent to QR, so QP is congruent to QR, so that's this segment and this segment, then which angles are congruent? Well, since we have this segment congruent to this segment, we know that by the base angles theorem, this angle has to be congruent to this angle. And so we say that angle P is congruent to angle PRQ. Angle PRQ. We couldn't say angle R because at that vertex, angle R would be ambiguous. All right. For problem 11, angle TRV, so this angle is congruent to angle TVR, so that would be this angle. This would be the converse of the base angles theorem. If two angles of a triangle are congruent, the sides opposite must be congruent. So we can say that segment RT is congruent to segment TV. Now for problem 12. RQ is congruent to RS. So RQ is congruent to RS, so we make a mark there. And by the base angles theorem, this angle would be congruent to this angle. So angle RQS is congruent to RSQ. So angle RQS is congruent to angle RSQ. And now on to problem 13. We have angle SRV is congruent to angle SVR. So SRV. So this we're going to try and draw three little marks in here. SVR. So 1, 2, 3. So this angle and this angle are congruent, which makes this segment congruent to this segment. So segment RS is congruent to segment SV. Segment RS is congruent to segment SV. And that concludes problem 13. Now on to problem 14. Now in this problem, we're to find the values of x and y in the diagram. Now here we have a fairly complex diagram with lots of interactions, and I've found that what works best is to fill in all the information that I can find out about this figure first, and then solve the problem at hand. Sometimes it takes a little extra time, but it saves time in the long run. So the first thing that I noticed, is that this triangle is equiangular. Well, if this triangle is equiangular, it's also equilateral, which means this side, and this side are congruent. So if this side is 5y plus 1, so is this side. And so is this side. So 5y plus 1, 5y plus 1. Now, let's look at this triangle. We can see that this triangle has two angles that are congruent, which means that this side and this side must also be congruent. So, since this side is congruent to this side has to be 26, since this side is 26. So let's go ahead and use that to solve for y. So here we have 5y plus 1 equals 26. Let's subtract 1. 5y equals 25. And divide by 5. Y equals 5. So that gives us the value of y. Now, if we look at this value, this vertex angle is related to these two angles. We know by the triangle sum theorem that the sum of these angles is equal to 180 degrees. So you might be tempted to think we can use that to solve the problem. But in fact, we don't even know the measure of this angle, So these two add another unknown into the equation, and we end up having a situation just with this information that would make it extremely difficult to solve. But look over here. We know that this triangle is equiangular. And again, based on the triangle sum theorem, that all these angles add up to 180 degrees. So this angle plus this angle plus this angle equals 180. And so each angle has to be equal. Well, if we take 180 and we divide it by 3, we get 60 degrees. Which means this angle is 60 degrees. So let's go ahead and write that in. This is 60. Now look at these two angles here. These two angles form a linear pair. So I know that this angle plus this angle adds up to 180 degrees because linear pairs are supplementary. So now we have a fairly easy way to find our measure of x. Okay, so let's go ahead and write 8x plus 60 equals 180. We'll subtract 60. 8x equals 120. And we divide by 8. So x equals 15. And so now on to problem 15. In problem 15, we're told to decide whether enough information is given to prove that a triangle LMP is congruent to triangle NMP using side-side-side congruence theorem. If so, write a proof. If not, explain why not. So, we know that this side is congruent to this, so there's one side of 3. We also know that NP is congruent to itself by the reflexive property, but unfortunately we're not given any information about any of these angles. We're not told that any sides are parallel, so we really don't have enough information to show that LP is congruent to MN. So our final conclusion is, no, there is insufficient information to prove the triangles are congruent using side-side-side congruence because we only know 2 of the corresponding sides are congruent. And now on to problem 16.